Hey, what's up guys? In this video I'm going to show you how to model both the NMOS and PMOS characteristic curves using Orcad. We'll start by creating a new project. You can name it whatever you want. I'll name mine MOSFET curve, and it's going to be a Pspice analog or mixed analog digital signal. Go ahead and choose your location where you want to save it. I'm going to save mine on my desktop. I've already created a folder named MOSFET curve. Go ahead and click OK. And you're going to want to create a blank project. So first we're going to model the NMOS, and we'll start by placing the NMOS on the blank sheet. And to do that we'll go to, we'll go to place, and then Pspice component, we'll go to discrete, and it's going to be a NMOS. We can place it on our sheet now. We'll zoom in a little bit. Next we're going to place some voltage sources, so it's going to be VDC. And we're going to want 3 of these. Zoom out a little bit. We're going to place our ground, which is going to be right here. We're going to need 3 of these as well. And then we can start making connections, and we'll do that by routing it with this icon right here, place wire. So we'll place this wire, and this wire. And of course we'll connect everything to our reference ground. And so far so good. Okay, next we're going to want to create a simulation profile. And to do that we'll go to this icon right here, new simulation profile. And we'll name it NMOS curve. We'll create it. And in this case we're going to want to do a DC sweep. And the first sweep we're going to want to vary is going to be the voltage source of the drain. So that's going to be V3. And we want to start at 0 and value 15 volts. And we're going to do increments of half a volt. Next, we're going to do the secondary sweep. And in this case, we're going to use voltage source 1 for our secondary sweep. And that's going to be the voltage source for the gate. Again, it's going to be linear. We'll start at 0, go up to 5 volts, and we'll do an increment of 0.1 volts. Click apply, and OK. Next we could place our probes. We're going to want to measure the current through the drain. There we go. That took a little bit longer than I expected. And then we could go ahead and run the simulation. And once that's done, the simulation should run. And you can see here a curve, the characteristic curve, and it looks like we might have did a little bit too many. So let's go ahead and edit our simulation. For the primary sweep, let's go to, okay, 15 volts is fine, half. For our secondary sweep, we'll go to, let's change this to 0.5, or even just 1 volt. Apply, click OK, and then we'll run our simulation again. And there you have it. So you have a little bit less curves, and if you want to change it, you could change the simulation settings again. So the more increments you have, the less curves you'll have. And this is going to be the curve for the NMOS. Okay, we can start with our PMOS now. And again, it's going to be a similar process. We'll just move this over here. To get to the PMOS, we'll go to Tools. Let's see, where was it? It was Place, Pspice component, go to Discrete, and we want the PMOS. So go ahead and place the PMOS right in here. Again, we're going to need a few voltage source. So I'll place one here, one here, one here. We'll place our ground. We'll place one here, and one here. Again, we'll place our wire. So this one connects to V6, this one connects to V5, and the gate connects to V4. We can then create our simulation profile. So we'll create a new simulation profile, and this is going to be the PMOS curve. Create. Again, we're going to be using the DC sweep, and for the primary, we're going to be using V6, and that's going to vary from 0 to, in this case, negative, well, let's do negative 10 volts with, well, so our N value is going to be negative 10, and we'll do increments of 0.5. And for our secondary sweep, we're going to be using V4. And we're going to start at 0, and we'll go to negative 5 volts, and we'll do increments of 1 volt. Click Apply, OK. We'll place our current probe, same thing right here. Run our simulation. And you should get something that looks like this. Again, if you want more curves, you can go ahead and edit your curves and place a few more, not few more, but less increments, so that way you'll get more curves. So that's it for the PMOS and NMOS modeling, and that completes this video.